Hi Saanika, welcome back. We can continue with that particular question paper which we were discussing. A glass prism has an internal angle 45 degree, 45 degree and 90 degree. The glass has a critical angle of 45 degree. What is the possible path? In these four, which will be the possible path? The question asks for the possible path. So, any guess on which will be the possible path? The correct answer actually is A. The correct answer is A. Why is it so? Any guess why the correct answer is A? It is because, so the critical angle theta c, critical angle is denoted as theta c. It means that light incident at 45 degree to the normal will refract along the boundary. If light hits the boundary at an angle greater than 45 degree, it will undergo total internal reflection, right? So remember, the if light hits a boundary at an angle greater than 45 degree, it will goes to TIR, total internal reflection. So what happens? The prism geometry is 45, 45, 90 degree. So light entering one of the 45-degree faces perpendicular will hit the hypotenuse at the 45 degree. So the light entering one of the 45-degree faces perpendicularly will hit the hypotenuse at 45 degree. Which is the hypotenuse here? Hypotenuse is this one. This is 90 degree, 45, 45. So hypotenuse at 45 degree. So this one is the answer. Moving on. A point source of light amplitude y is viewed from a distance x. So a point source of amplitude y is viewed from a distance x. If the observed light intensity is I, if the amplitude is now decreased and distance changed to x by 2, if the observed light intensity become 2I, what is the new amplitude? So how can we find the new amplitude, Saanika? It's very easy. What is the formula? We have the ratio intensity. We have the ratio intensity. We have the ratio intensity. I is proportional to y square by x square. Because we know light intensity I is proportional to the square of the amplitude y and inversely proportional to the distance. So I is directly proportional to y square by x square. Given initial intensity I is equal to y square by x square. So now set up distance at x by 2. So we need to set up this as x by 2. So what will be the answer? Y square by x by 2 the whole square. That is into the new ratio will be y square by x by 2 the whole square. So what will be the ratio? 2y by I. 2I by I is equal to 2I by I is equal to y square by 2 by x by 2 the whole square into x square by y square. So we can write 2 is equal to y square y2 square by y square into 4. That we may write y2 is equal to the new amplitude y2 is equal to y by root 2, that is root 2y by 2. So the answer is D. So I hope you got this thing. We have to find the ratio. That's an easy question actually. I'll explain once again in short. We just need to use the equation. I is proportional to y square by x square. So now we set up x as x by 2 for the second case. So we found the ratio. As the intensity at that point is given as 2i, we can write 2i is equal to y square by x square by 4. That is x by 2 the whole square. Just take the ratio, we will be getting this. Perfect. So we will be just getting what is y by, this is y2. We will be getting what is y2, the new amplitude. Okay, perfect. Moving on to the next question. Electrons are moving in a wire that is normally placed Electrons are moving in a long wire that is normally placed normal to the plane of the paper. If the electrons move into the paper, okay, the electrons move into the paper. What is the direction of magnetic field at point P? What is the direction of magnetic field at point P? So, what we need to find, what are given? Electrons are moving in a long wire that is normal to the plane of the paper. So, a long wire that is normal to the plane of paper, that means perpendicular. The electrons move into the paper. Electrons are moving into the paper, right? So, what we have to do is that we have to use the right hand rule. Electrons move into the paper. So, conventional current direction is out of the paper. Electron move into the paper, so the conventional current will be out of the paper. Right hand rule, point your thumb in the direction of conventional current out of the paper. Your fingers curl the counterclockwise around the wire. So the magnetic field at point P form concentric circles. It will form concentric circle. Let us see some options are there. Oh, it will form concentric circle. It's not an MCQ, I guess. It's like it forms concentric circle. Oh, the electrons move into what is the direction? Oh, there you have just marked the direction. Okay, so your finger, the magnetic field at the point P forms concentric circle counterclockwise around the wire. Concentric circles counterclockwise around the wire. So the correct option will be what? Option C. It's very clear. It's option C. Assuming we assume actually that the this actually corresponds to the clock and the counterclockwise direction. So the option is option C. Perfect. So please note it down. Moving on to the 19th question. Yeah, 19th is easy. What is a possible unit of electric resistance? What is a possible unit of 19th question? The electric resistance. What is electric resistance? You know what electric resistance is? V by I is equal to R, right? But here we don't have anything that connect V and I. So there is some difference we have. So it's something related to power. So how can we write power in terms of V or something like that? So we have power is equal to voltage into current. We have power is equal to voltage into current, right? So W is equal to A into V, right? So we have resistance is equal to we can write we can write V as W by A. We can write V as W by A. So that will be W by A by A. That is W by A into 1 by A. That is W by A square. That's W A raised to minus 2. So the unit is W A raised to minus 2. So we have used, see, this is not a direct unit they are asking for. We have to find the relation between power and current, then substitute it to V. Just in the thing and just substitute it to V. Okay. So moving on to the 20th question. Four circuits are available for an electrical experiment. The internal resistance of the cell in each circuit is negligible. In which circuit can the current in the lamp be verified by adjusting the variable resistor? So in which circuit it can be? So to vary the current in the lamp, the variable resistor must be series with the lamp. To vary the current in the lamp, first thing you have to note is to vary current in the lamp, the variable resistor must be in series with the lamp, should be in series. Right, it should be in series with the lamp. So, the total resistance is the sum of the lamp resistance and the variable resistance. If it is in series, the total resistance will be the sum of the lamp resistance plus the resistance of the variable resistor. By adjusting the variable resistor, the total resistance changes, which alters the current through the lamp via Ohm's law. So, which one will be then? Then it's very clear which of them is connected in series. A, right? So, this will be the answer. So, what should be the answer? Resistors should be connected series with the lamp to change the current by changing the variable resistor. This should be the answer. So, I guess that is clear for you. Moving on. To the 21 question, a variable resistor with resistance range of 0 to 6 kilo ohm is connected series with two resistors of fixed value 6 kilo ohm. The cell in the circuit has an EM of 18 volt and a negligible internal resistance. So, negligible internal resistance. So, what we need to find? What is the maximum range of potential difference? What is the maximum range of potential difference that can be observed between X and Y? So, there are 2 points X and Y in the figure. You can see in the figure actually. So, to fixed resistance 6 kilo ohm, variable resistance is 0 to 6 kilo ohm. So, total resistance as in series will be the answer. Okay, so the answer for this question is actually 9 to 12 volt. How can we get 9 to 12 volt? Any guess? So we have an 18 volt battery. So the total resistance, R total will be from 12 to 18, right? It will be from 12 to 18. Why 12 to 18? Because this and this are fixed, like 6 plus 6 is 12, and this is from 0 to 6. So 6 plus 6, 12 plus 0 is 12, and maximum is 6 plus 6 plus 6 is 18. So the resistance will range from 6 to 18. And the voltage, what will be the right voltage? 12 by, it will be like 12. We have 18 volt. So what will be the voltage? I think the R total is clear for you. We have the three resistance, 6 kilo ohm, 6 kilo ohm, and zeros to 6 kilo ohm. So the range will be 6 plus 6, 12 plus 0. That is 6, 12 kilo ohm to 6 plus 6 plus 6, 18 kilo ohm. So these are the minimum and maximum resistance available. We need to find the maximum potential difference that can be observed between X and Y. Okay, one second. We need to find the maximum potential difference between X and Y. Yeah. So it will be 6 kilo ohm, 9 volt to 12 volt. Understood? It will be 9 volt to 12 volt. I will give an explanation to that. I think I need to give you one. 1 second. One, right? Yeah. So the answer will be, I'll explain the answer for you. Total resistance is between 12 and 18. The potential difference across X and Y is Vxy equal to I into 6 plus RV. What is RV? The variable resistance. So when RV can be varied from 0 to 6, right? So Vxy will be I into 6 plus 0. It can vary up to I into 6 plus 6. So the answer will be this one. What is I? How can we find I? I is nothing but 18 by R total. So 18 by R total. So 18 by R total, what will be the R total? It will, if it's 0, it's 18 by 12. If it's 18, if it's 6, it will be 18 by 18. So I varies between 1.5 and 1. So here it will be 1.5 when it's 0, and here it will be 1. So the answer will be 9 volt to 12 volt. So that's all for this particular session. We'll continue with this question paper in the next video.